Okay, we are going to continue talking about putting equations into slope-intercept form, and something new today is going to be talking about standard form. So before we get to that, we do need to do a warm-up of reviewing putting equations into y equals form. This is extremely important for this chapter. You want to make sure that you're really good with this. And then yes, I'm going to go over the homework solutions so that if you have questions on any of them, I can make sure I address those before we move on to the lesson. Homework tonight, there's not going to be a ton because the lesson we're talking about today is completely different from the lesson in the book. So I don't really have much homework to give you. The important thing for today is that you truly and really listen in class and make sure if I am not making sense that you tell me. This lesson is very, very important. There's a lot of things that you need to understand for today. This chapter as all, but this one's a little different, builds. Every lesson builds on each other. So after we get through the first 7 lessons, you'll be able to graph an entire problem and write an equation in all different forms that you're going to learn. So you want to make sure that you're really listening in class. I know you guys look tired today, and I know sometimes early in the morning it's tough, but you got to do your best to make sure you're listening in class because there's not a ton of homework. Okay, so let's start here. Number 1 on the warm-up. Let's just go around and I need you to tell me the answer, and if you don't know how that person got it, I'll go back and do it. Helene? Good job. There's number 1. Garrett, number 2. Okay, keep going. Equals. Okay, one more step, Garrett. What else? So remember yesterday, I would circle the y. You have to get y by itself. How do you get rid of the -4? So it's really -4 times y. What's the opposite? Good. So you now need to divide every term by -4. So this cancels. You have y equals 7 over -4, or -7/4 x. Okay, and then 16 divided by -4 is -4. That's why we're doing this today. Make sure you do that. Got it? Okay, so there was 2. Melissa, what did you get for number 3? 4x plus 30. No. What did you do first? Did you show your work? Okay, so minus 8x minus 8x. This goes away, right? You're left with -20y equals -8x. Move this. Minus 60. Okay, so you just wrote it wrong. Okay. Those of you that had 20, Jackie, what did you have for your answer? Good. Raise your hand if you got all 3 of those right. Nice and high so I can see it. Okay, raise your hand if you missed one of them. Okay, if you missed one, you know what you did wrong? Okay, any questions on any of those 3? Okay, let's go over homework. I'm just going to go around the room. I'm going to ask you because I want to make sure that you guys are getting these right before I move on. Okay, 3.8, Mamta, number 1. Good job. John, number 2. Okay, but what always has to be first? Yeah, mine is just what you want to do, right? That's so annoying, isn't it? -17x plus 6. Number 3, Helene. Good. Y equals 3x plus 11. The answers are up here, so if you didn't hear someone, they're up there. Jake, number 4. Good job. Number 5, Heather. Good job. Number 6, Will. -1/2 x plus 2. Good. Patron, number 7. Good. To keep the x there. And then one more little thing. Negative divided by negative is a positive. So you can get rid of both of those negatives and write it as +5/7. You okay? Okay. Okay, number 8, Haley Waters. No? Don't have that one? Sam, number 8. Okay. You just forgot? Okay. Okay. Amanda, number 8. Good job. Number 9, Maggie. Good job. Matthew, number 10. Good job. 11, Dirk. Good job. Number 12, Amy. 4x minus 8. I just didn't hear you. Okay, there's all the answers. Make sure you've checked them all. If something was wrong, make sure you wrote the correct answer down. Does anyone need me to go over any of those? Have any questions on how to do something? Thank you. Are you positive? Okay, real quick show of hands. If you got all of them right, raise your hand. Okay, good. Miss 1, raise your hand. Miss 2, raise your hand. Okay, if you missed something, give me a head nod. Do you know what you did wrong? Okay, you sure there's no questions? Okay, let's move on to notes. So I need you to open up your note packet to page, I think it's page 3 in yours. Yeah, it should be page 3 in yours. Yep, page 3. We just went over, yeah, thank you. And Sage, when I'm done with the notes, I'll give you my answer key. Who said my name? Yes. Are there more golf pencils over there? You don't have any writing utensil in your locker? No? I have some. It's okay. Thanks, Will. Will has one with an eraser if you'd rather use that. You gotta make sure you bring something to write with in school. No, don't throw. I'm sure you can throw pretty well, but don't throw. Sage, at the end of class, I will give you my answer key, okay? All right, so page 4 in the notes, at the top it says section 4.2, linear functions and slope. All right, so here's the lesson where there's not much homework to. You need to make sure that you're listening as much as you can. The objective is to write equations in slope, intercept, and standard form from a given scenario. So there is so much application in here. Does anyone know what is the general form for slope-intercept form? What's the general equation for slope-intercept? This is from last year. I didn't really tell you this yesterday. Will, do you know? The slope is rise over run, but slope-intercept form is y equals something x plus something. Chastity? Good. Slope-intercept form, we're going to talk about today, is y equals mx plus b. I'm just seeing if you know this. Does anyone know what standard form is? This you may not remember. Zach, do you remember? Okay. There's an A in it, a B in it, and a C in it. Melissa? Good. AX plus BY equals C. Do you remember learning this? Give me a head nod. Just curious. No? Okay. Didn't think so. So anyway, we're going to talk about those two forms today, as well as writing equations given a scenario. Okay? Bear with me. There's a lot of stuff in this lesson. First thing we need to fill out is there is a little box or chart at the very top page of your notes. First thing is just a little review of linear functions, which the first thing you have to fill in is the highest exponent, on the x variable is a 1. So if it's a linear function, the highest exponent on the x variable is a 1. In a quadratic function, it was a 2. We're now, for the rest of the year, we're on linear functions. So the highest exponent has to be a 1. The graph of a linear function is always a straight line. No more of those U-shaped graphs for now, at least until we get to our final exam. They are always going to be a straight line. Whether it's going up or going down depends on what the equation is. Okay, next part of the little box there, it says there are 2 different types of linear equations. In other words, there are 2 forms that you can write an equation in. There's slope-intercept and there's standard form. The first one I want you to write down is slope-intercept form, and this is already written for you, but I want you to put a box around it or underline it. It's extremely important that you remember y equals mx plus b is a form for a linear function. You always need to make sure that is the form it's in when you are graphing. And that's not part of today's lesson, but it's something I want you to try to start remembering. So slope-intercept form is form number 1 for linear functions. Form number 2, and there's a lot I have to say about this one, is standard form. And I'm actually going to make these capital. AX plus BY equals C. You typically see them as capital letters. AX plus BY equals C. Standard form is the second form that you can write linear functions in. Now, there are restrictions with standard form. There's 3 things I'm going to tell you. The first thing is A, B, and C will always be a real number. In other words, A, B, and C will always be a number. This is going to be a number, this is going to be a number, this is going to be a number. All of the exponents, the highest exponent is still a 1. So you're not going to have any issues with these exponents changing. It still has a power of 1. Second thing, I need you to circle or underline. A and B cannot be fractions. That is really, really, really important. So either underline or circle. A and B cannot be fractions. That is only in standard form. We will do plenty examples with it so that you get practice with that. The last restriction for standard form is the A cannot be negative. So I'll say this again. A and B cannot be fractions. A cannot be negative. Okay, so a quick summary. Slope-intercept form is y equals mx plus b. That is the graphing form for linear functions. Standard form, which is ax plus by equals c, is another form for linear equations. A and b cannot be fractions. A cannot be a negative. Now, a fraction and a decimal is the same thing. So A and B can also not be a decimal. So don't say, oh, it's a decimal, not a fraction. Same thing. Okay, so make sure A and B are always integers. They're always nice numbers. Any questions for me on all this information? Okay, let's go to example 1. All right, before we start, every single one of these examples, I want you to make the same or have the same format and stay with me on them. The first thing I need you to do is above number 1 or below, wherever you have most room, I want you to put underscore, depends on underscore. So put like a line. We're going to fill it in a second. So a line depends on a line. Oh, down here. Underneath or above example 1. Oh, down here. And then underneath that or underneath 1, kind of like I did, I need you to put x equals and put y equals. You with me? Right here. Number 1. Above or below. Like maybe like put it here. Wherever you have room, above or below. Depending on how big you write, doesn't matter. Sorry, I should have left you more room in the packet. And then one more thing I need you to do before we get started on this is make a table, a t-chart, which is just an x and y table, in between where it says slope-intercept equation and standard form equation. Okay, ready? I'm going to read the scenario, and we're going to go through this one thing at a time. The first thing we're going to do is identify what x and y are. So it says here, Michael has run 3 miles this week, and he runs 2 miles every day. Think back to word problems. We first need to address and figure out what does x mean in this scenario? What does y mean in this scenario? Before I give you any hints, does anyone have any idea what x means in this scenario and what y means? Melissa. And y means what? You are close. You gotta get more specific. So x is one word, y is one word. Anyone have any idea? Zach? Close. X is days, and I'll explain why in a second. But y is miles. 2 miles every day. 2 miles every day. The x variable is always something that you cannot control. Can we change that there's 7 days in a week? No. Can we change how many days are in a year? No. The time aspect of a scenario is always the x variable. I shouldn't say always. Most of the time. So x is days. Y is miles. Miles is something that you can control. We can decide, okay, we're going to run 1 mile every day. or we're going to run 0 miles every day. We're going to run 10 miles every day. Whatever it may be, you can control that. Okay, let's go up here. Based on these, which one of these depends on what? So based on these two, we need to fill these in for the spaces. Something depends on something. How are we filling that in? What depends on what, Heather? Good. Y, put it underneath. Awesome. Y depends on X. Now, since Heather mentioned that first, we talked about this with quadratic functions. Remember, like the cumulative exams, the fill in the blank? Y always depends on X, and you got really annoyed with all those fill in the blanks. Y always depends on X. So listen, let's see if this makes sense. Miles always depends on, in this scenario, days. Is that true? Does the amount of miles depend on what day it is? Yeah, in this scenario it is. How many miles Michael has run or ran, whichever one it should be, depends on what day it is. Maybe it's Wednesday and he ran 2 miles every day. So we can add up the total to see how many miles he has run so far this week. Y always depends on X. In this case, miles always depends on day. If you want to start from this to determine what X and Y are in this scenario, that's fine with me. Okay, give me a head nod. Are you with me? Give me a head nod. Are you tired? You guys look so tired. Okay, stay with me, okay? Next thing we need to do is we need to go to slope-intercept form equation. So without looking, what is the slope-intercept form in general? Y equals, Will? Good. I want everyone to write down Y equals mx plus b. So I want everyone to write down slope-intercept form is Y equals mx plus b. Based on this scenario, this is just like word problems. Does anyone know what the equation would be based on this scenario? I'm just curious before I start explaining all of it. No? This is just like a bunch of the word problems we did in chapter 6. Okay, so let's start here then. Michael has run 3 miles this week. That is what he has already done. So the plus 3 goes where the B is. He's already run 3 miles this week. So that goes where the B is. It's just plus 3. 2 miles every day. Think back to word problems. When I was explaining to you, the number in front of X is your rate. It goes with the keyword per, every, each. Anything that means on a routinely basis. 2 miles every day. That 2 has to go next to X. Every, each, per, any of those keywords, that is your rate that goes in front of or next to X. What you've already done is the plus or minus whatever this is. One more thing you could do, and you don't have to, you could put the Y is miles equals 2 times day plus 3. You don't have to, but one other thing you could do to make it easier for you is just rewrite for yourself Y means total miles, and then the X is days. So it makes sense, you're running 2 miles every day, so 2 times the number of days, plus 3, because you've already run 3 miles, and then all of that is equal to total miles. Is this easier than I'm making it? Is this easy? Okay. I can't tell, you guys are all sleepy. Okay, let's go to standard form. Without looking, what is general equation of standard form? Here's a hint. Amanda? Good. AX plus BY equals C. I want everyone to write that. Standard form is AX plus BY equals C. I then want you to, rewrite the slope-intercept form underneath. So rewrite the slope-intercept form underneath. And now we need to put this in standard form. How can we get this X term to the other side? Amy. Good, subtract it. We need to get 2X to this side. To get it to the other side, you have to subtract it. So minus 2X on both sides. It cancels here. Should we write the X term first or second? Where should it go so that it looks like this? First, right? So negative 2X plus y equals 3. Rewrite your 3. All right, what's wrong with this, John? Good. A cannot be negative. A and B can also not be a fraction, but we don't have an issue in this problem. How do we get rid of the negative? Jackie, you have an idea? Good. Awesome. You can either divide every single term by -1 or multiply, which I'm going to do, every single term by -1. Now, does it matter if you choose to multiply every term by -1 or divide every term by -1? No, not at all. After you distribute -1 to everything, we have 2x minus y equals -3. That is our standard form equation. That's it. One more thing I want to do, but before I do that, any questions so far? Okay. Let's look back at our slope-intercept form, and I just want to fill out 3 values on our table. Okay, based on the slope-intercept form, we know that x is day. So let me ask you this. At day 0, how many miles has Michael run? Zach? Nope, at day 0, careful. At day 0, look at the equation. If day is 0, how many total miles has he run? Well, how do you know that? Awesome. At day 0, that's why I wrote this out like this. At day 0, 2 times day 0 is 0, plus 3 is 3. He has run a total of 3 miles. Okay, someone else. At day 1, how many miles has Michael run? Sage. Awesome. 5. That was after day 1. How does Sage know that? 2 times 1 is 2, plus 3 is 5. All right. Someone else that hasn't answered. At day 2, how many miles has he run? Helene. Awesome. 7. Let's do one more. At day 3, how many miles has he run? Mamta. Good. 9. What is the pattern that you notice? Anyone notice a pattern in that table? Helene, what's the pattern? Good. They're all odds. What else? Jake? Awesome. The total miles increases by 2 every day. Isn't that what the problem says? 2 miles every day. 2 miles every day. Okay, you should be really good at that scenario. Any questions on that one? Okay, let's do one more together. Then I'm going to have you try one or a couple. All right, I'll go a little bit faster through this one, but just stay with me. Okay, scenario number 2, or example number 2 says Jen weighs 200 pounds and loses 3 pounds every week. First thing I need you to do is set up your problem, make your line depends on line, like don't write out the word line, make a line, and then put x equals y equals underneath the example or near the example and make a little T-chart or table like I did. Let me go ahead and get that set up before we start. Okay, anyone want to try to tell us what is x and what is y in this problem? Anyone want to try? X is something you can't control, y is something you can control. Heather? X is, say that again, good week. Heather, and y is? Good job, amount of pounds or weight. So number 2, good job. X is week, y is weight. X is weak because that's something you cannot control. Y is weight because most people can control that, right? Unless you have a health issue, but most people, you can control that if you exercise. So what depends on what? What depends on what, Amanda? Good job. Weight depends on week. In other words, Y always depends on X. Weight, your weight depends on what week it is if you're having some kind of competition. Anyone watch The Biggest Loser in here? You can kind of think of that, right? I've seen it a couple times, but I don't watch it very often either. So weight depends on week. X is week, Y is weight. Okay, next thing, slope-intercept form equation. I want you to write down y equals mx plus b. Okay, what are we replacing b with in this equation? What are we replacing b with in this equation, Zach? Awesome, why? Good. The original weight is 200. So the plus 200 is like your starting point. That goes in for b. Okay, what goes in for m? Sage. What kind of 3? Well, think about it. This person is losing minus. So it's kind of like the word problems. It's like you're losing money or losing something. Okay, and not just, that's for everyone. So negative 3x because this person is, Jen is losing 3 pounds every week. We're in the notes on page 4. Sorry, back shelf. There's a pink and a tan one. My fault. So negative 3x plus 200. If you're losing something and the rate or what's happening routinely, in this case, is going to be negative 3 pounds every week. Your key word for rate or changing on a routinely basis is every in this one. Okay, I want you to fill in week, because y is week, equals 3. Oops, I didn't mean to do that. My fault. Y is weight. I can't read my own writing. Sorry. Weight, that's y, is equal to 3 times week plus 200. Your total weight is equal to 3 times the week it is plus 200. So your total weight is equal to 3, because you're losing 3 pounds, negative 3. My negative's right here, you just can't see it. Times week plus 200. Okay, Haley Waters, you okay? Okay, let's go to standard form. Standard form is ax plus by equals c. Underneath standard form, I want you to write down the slope-intercept form equation, which is y equals negative 3x plus 200. How will we get that into standard form? How do we get that in standard form, John? Add what x? What kind of x, though? Good. Add 3x to both sides. So we have 3x plus y equals 200. And do we have to change anything? Do we have to fix anything? Nope. The 3 is positive, and a and b are not decimals and not fractions. So that's it. So there was our standard form. Here's our slope-intercept form. One more thing we need to do is fill in our table. Okay, so let me ask you this. At week 0, how much does Jen weigh? At week 0, how much does she weigh? You should all have your hands up because that's easy. Sam? Good, 200. At week 1, or after week 1, Jackie, how much does she weigh? Nope, careful. At week 1, so negative 3 times 1. Say that again. Nope. Look. Negative 3 times 1 plus 200. So it's negative 3 plus 200. So she's losing 3 pounds. Good, 197. You understand that? Okay. So be careful because she's losing 3 pounds. So this is going to decrease to 197. After week 2, how much does she weigh, Jake? Good, 194. Let's do one more. At week 3 or after week 3, how much does she weigh? Amanda? Good job, 191. What is the pattern that you notice here? What's happening in the table, Helene? Good. This part here is going down 3. She's losing 3 pounds every week. With me? Okay, I need to do one other different type, so flip over to number 5, please. Okay, and the only thing I want you to do on your own on number 5, because there's something I haven't told you yet, is I want you to find what depends on what, find x equals y equals, I'll put little stars here, and tell me the slope-intercept form and then stop. So on number 5, only set up and find what I have a star next to, and then I need to do the rest of it with you because it's a little bit different. So number 5, just where I have the stars. works actually. You guys are doing well with identifying what x and y is. Okay, so I know some of you are still finishing up, but let's start going over this together. Okay, what is x and what is y in this problem? Dirk, what did you put for x? What means? Good. X is day. Maggie, what's y? Go ahead. Well, you are right, but give me one word that describes y. Yeah, cents or money. Either one's fine. There's going to be a variety. So cents or money doesn't matter. So in this case, the total money or total cents depends on what day it is. Y depends on x. Guys okay with that part? Okay, Reno, what is the slope-intercept equation for this one? Okay, and then what did you plug in for this scenario? Okay. Zach, what did you plug in for this scenario, for the slope-intercept form? Okay, you're close. Anyone know what needs to be changed a little, Matt? Okay, why? Good job. So somehow Emily, she has $15, but she loses a quarter every day. If you're losing something, that rate, that number next to x has to be negative. Loses 25 cents every day. That loses means negative. Every day, that's the key word for that has to go next to your x. Negative 0.25, do not leave as a decimal. You need to convert it to a fraction. This is what I have not taught you yet. So negative 0.25 is what fraction? Jackie? Good job. Negative 1/4 x is what negative 0.25 is. If you cannot do that mentally, remember you have your calculator to type in negative 0.25 and then math, enter, enter. So you have your calculator to type in negative 0.25, math, enter, enter. Okay, Maggie, yours doesn't do that, right? Okay. If you need to borrow one of mine during a test, I'll give that to you. Okay. Any questions on how to get this? Okay, one more thing I want to do with this is put this in standard form. So let's move this over to standard form. We have y equals negative 1/4 x plus 15. Okay, Katron, how do we get negative 1/4 x to the other side? What's the opposite of minus? Good, so when you want to add 1/4 x to the other side, you're thinking of the next step. Okay, so add 1/4 x to both sides, get that to the other side. So we have 1/4 x, always write the x term first, plus y equals 15. What's wrong with this? This is wrong in standard form. Sage. Good. A and B cannot be a fraction. Matt, you have any idea how we can get rid of 1/4? Good job. Multiply the entire equation by 4. Raise your hand if you were already thinking that. Okay, good. Multiply the entire equation by 4. This 4 needs to be distributed to every single term. Anyone want to try to tell us what it becomes? Okay, 4 times 1/4 is 1, so we end up with 1x or just x. 4 times y is 4y. 4 times 15 is 60. That's the answer in standard form. Don't worry about the table on this one. Will, you okay? Questions? Okay, give me a thumbs up, thumbs up, thumbs down before I explain your homework. What'd you think of this? We're going to do more of it tomorrow. You guys are just my baseline for the rest of the classes. Okay, thank you. Okay, homework. You are going to do numbers 6, 7, and 8 in your notes. Now, I will warn you, there are decimals for these, so please make sure that, like, for number 6, 0.75 is really 3/4. So convert your decimal to a fraction. You need to make sure you look at the smartboard and you're setting it up as what depends on what, x is what, y is what, and make a table. So you need to do it just like we did 1 and 2 in the notes today. Number 5, I skipped the table just because of time. So you only have 3 problems. Please, please, please try them on your own. Any questions for me? We will do more of these tomorrow. I'll make up some more scenarios for us. Okay, you good? Okay, have a good day.